Hello and welcome to session 334 in the AISafety.com reading group. Tonight we'll discuss the article 6 Reasons Why Alignment is Hard Discourse Seems Alien to Human Intuitions and Vice Versa by Stephen Burns. This article is Stephen Burns' attempt at getting a handle of a debate he labels cursed. And his own side, Stephen calls that technical alignment is hard. I think that's a really good label. It certainly identifies me. So we, our side, believe that future AIs will be strongly goal-directed and instrumentally rational, and that's a lethal combination for humans. And then there's the other side, which is a position that Stephen just labels as the other side. And here it's observed that current humans and current LLMs are empirically not cold-hearted consequentialists. And both are true, right? But the other side here isn't really answering the arguments that the technical alignment is hard side is bringing, at least in Stephen's telling. So I don't necessarily think Stephen is inaccurate, but I think this is not the most charitable start. I want to dwell a bit more on the point of labels, because what labels should we use to refer to those who hold this belief that we just expressed? One option would be AI optimists, which is a name chosen by a group that holds roughly these views, right? It's unfortunately a defunct group now, so that might not be the best name. I propose value empiricist because it seems like a side that holds that the values that we empirically observe the AIs espouse are a central piece of evidence about their actual values. And so with this framing, Stephen kind of ironically phrases the opposition to this piece of empiricism as requiring a belief that contradicts your own eyes. And there are, in fact, a number of people that I would call value empiricists that are working at the frontier AI corporations. This includes people like Ivan Hubinger, Irsan Perez, Jan Leike, Rohin Shah, and quite a few others. But there are, of course, many more value empiricists that are outside the labs. But these people have a much more filtered view of the evidence. Because they can't see the base models. There's a lot of things they can't really see. So there's a sense that these people ought to be much, much less certain about what is behind the curtain. I would also point out that the people who actually know are mostly not really interested in this debate and not really participating in it. So there's a sense here that we may, in fact, not be debating like empiricists that have actually seen things, but more like straw empiricists. Stephen Burns builds his 6 reasons for discourse failure from a single underlying crux. This crux or explanation starts by answering the question of why humans that are the only general intelligence are not consequentialists. And Stephen's answer to this is that we are instead motivated by what he calls approval reward. And we'll be diving a lot more into that in just a moment. But bear with me for now. Let's think of approval reward as a non-behaviorist reward function that is used for reinforcement learning. So a reward function that doesn't refer to your behavior, but your internal states and beliefs. And this is also used in Stephen's answer to the related question, why aren't the GPTs that we see just ruthless maximizers? And in Stephen's answer, this is because GPTs are 99% human imitators. And so if the humans have approval reward, our imitators will as well. But the 99% does really not fit with my intuitions. I've tried to interact with both fine-tuned models and base models. I haven't actually interacted much with base models recently, but there's a sense that it's very different to interact with a modern LLM like ChatGPT compared to base GPT-3 or something like that. In particular for tasks like coding, the ability to just get stuff done is really, really different. So I feel these models are much more goal-directed and optimized. So if I had to guess, I'd say at least 60% influenced by reinforcement learning, but that's of course difficult to say with any kind of precision. So here is, in fact, a substantial difference between my model and Stephen's. But this isn't like the crux that this article is about, because this is not between like internal on our side. The crux rather is the following. Will future superintelligences and AGIs have approval reward? And Stephen asserts that the general cause of this empiricism culture clash is that we have opposite predictions on that specific questions. So I agree it's an important and central question, though Stephen might be overselling his claim a bit here, right? There are many other cruxes, like to what extent is it beneficial and ethical to contribute to capability research, and probably there are many other reasons. Okay, now I will attempt to summarize Stephen Byrne's concept of approval reward. Brains in general include a simple reinforcement learning algorithm, right? That's basic biology. There's a reward signal if you obtain food, and there's a punishment if you have pain, and that's how lizard works, and that's also included in the human brain. But human brains have more, and we have what Stephen calls a compassion/spite circuit, which is a moderately complex structure that Stephen argues for. But the evidence Stephen brings is mostly from evolutionary psychology, and that's a source where I'm often pretty skeptical. But like, I'm noting this explicitly because I don't actually have the ability to evaluate Stephen's argument. So for now, we're just going to have to roll with it. Okay, the compassion-spite circuit behaves in different ways depending on the social circumstances. So there's a way it works for friends and for foes, and it also depends on whether the person that's the object is thinking about us or it's thinking about the person with the brain. So that gives 4 options, and approval reward is the specific reward signal when people who are in the friends category are thinking about me. So this signal fires to give reward when your brain believes that they have a positive approval of oneself, and conversely it also gives negative reward or punishment for disapproval. But crucially, this generalizes very widely for humans, because it's not just your friends, it's also your idols, and it includes not just you, but your outward actions as well. And it's approval of things that I do and things that are related to me. So it's a pretty wide circuit. And humans uniquely generalize even further than that. So we're not just talking about actual situations, but also imagined situation. So in this imaginary situation, would my friends approve of me? And that's the part that causes humans to enforce norms and even take pride in enforcing norms. And Stephen holds that this is a really, really central part of the human psyche. He claims that this circuit fires 10,000 times per day for each of us. And that's, of course, a claim that I cannot evaluate in any way. But I think it does sound somewhat reasonable. Now, to see how approval reward fits into modern artificial intelligence, Stephen introduces a spectrum of superintelligences. And he doesn't name the spectrum, he just lists categories. I think it would be really nice to have a name. So I would call it something like, how much is the superintelligence shaped by reinforcement learning? I think it's Stephen who should name it, and it's probably a sign of some confusion that he doesn't name it. I'm certainly confused, and that's why I give it a pretty bad name. And to show how my name is bad, at the very top end of the spectrum, the name mostly falls apart, because at the top of the spectrum, we have the perfect instrumentally rational agent, a consequentialist maximizer. That isn't what we're really talking about here. We're talking mostly about the lower levels, where we have AIs that he called reinforcement learning agents. So AIs that are centrally trained through some variation of reinforcement learning. And then at the bottom, we have what Stephen calls LLMs. And that's basically the models that we're currently seeing. I'm not perfectly happy with this structure. I feel the word agent really doesn't cut it very much at the joints, because you can make any base model an agent through some scaffolding. Like, that's not really a good description of what the RL is, what it is to be RL shaped. So instead, I'll introduce my own more fine-grained spectrum with not more categories, but with more examples, which I feel better illustrate the spaces of like realistic or possible options. So like Stephen, I put a hypothetical paperclip maximizer at the top, or IXI or something like that. Those aren't really important. We'll see that in a moment. But for the most RL-shaped AI, I would give AlphaZero as a central example, because AlphaZero is trained to play Go using reinforcement learning and nothing but reinforcement learning, only self-play basically. And so we have other models that use reinforcement learning with verifiable rewards. ChatGPT is in fact trained in this method, it is believed, and I think this is pretty important. And then we have earlier models of ChatGPT, one level below, which is a base model that has been trained with reinforcement learning from human feedback. And that's also one of the models that we'll return to. And then finally, at the bottom, I think we have the base pre-trained models, which are just language models, self-supervised, no reinforcement learning, no fine-tuning, no anything. So here's a spectrum, and let me try, because I can't really define it in a rigorous way, let me try to put it into words. So there's a sense that the ones highest at the top have more goal-directed coherence. Obviously, a paperclip maximizer is totally coherent. And so there's also a sense that for the bottom, the lower you get in this spectrum, the more of the optimization happens at train time, like in the policy. But at the top, the optimization is at test time. And there's also a sense that the base models basically have no training against themselves, or training on their own policy, but AlphaZero basically only has that. Another way you could like graduate this is like reinforcement learning from human feedback can be more or less radical. We can define that as basically the KL divergence, Kullback-Leibler divergence, which is kind of like a leash towards the human baseline. Like, how far do you get away from the base model? And for Stephen, this is really, really important, because one thing he believes is that the current LLMs and the current paradigm is fundamentally imitative, and there's no way it can actually scale to ASI, artificial superintelligence. And I think I would disagree with this, because they can't just model humans. They have to model at least humans plus the world in order to predict tokens. And that is, in fact, already a lot more than humans. So I would not be surprised if a self-supervised base model could, in fact, become a superintelligence. But we have more than that. We are, in fact, doing a lot more than just pre-training. So now we're able to formulate the main crux. Will artificial superintelligence have approval reward? Well, for the top of his list, consequential rational agents, Stephen asserts that it's basically theoretically impossible, right? Because approval reward is not a consequence. So it's not something you can maximize. And it seems plausible to me that we could, in theory, build an almost consequentialists that include approval reward. But that isn't really the topic here. Now for RL agents, it would have to be included in the reward function explicitly, right? This is not something that will happen in other ways, according to Stephen. Notably, current RL agents don't really include anything like approval reward. They only consider the external behavior of the model. And I'd be a bit curious in how Stephen rates constitutional AI, because that does kind of seem like at least an honest attempt to do something vaguely like this, like non-behaviorist. So on the lowest level, we have large language models. This is the category where Stephen basically puts all the current frontier models. And these, he claims, fundamentally get their power from human imitation, and they do imitate humans, right? And so they do in fact display substantial features that are the same as humans having approval reward. So it is in fact possible that there is something like approval reward going on within the giant inscrutable matrix. I think if there is any, it's probably going to be stamped out as we move up towards rational agents. And that's basically what the labs are spending most of their time on, as far as I can see. And we have been trying to move up in a sense since basically reinforcement learning from human feedback started. And there is in fact a lot of research going on. There is RL AI feedback. I talked about verifiable reward, and there's group relative policy optimization, WebGPT, and so many other things where we are trying to push up. And since we expect rational agents to be more optimal, then there's a sense that we should in general expect movement away from human imitation. Consider how AIs and humans get preferences when they reflect over themselves and reflect over the preferences of their preferences. Now, for classic reinforcement learning and consequentialists, everything starts with the object level. Like for humans, it's food. For non-human animals, it's food. For a paperclip maximizer, it's the actual physical paperclips that matter. So reinforcement learning will often generate or find some kind of object level desire, because it consistently leads to an ant finding more food, that it has a desire to find food, and it leads to more paperclips produced if you have a desire for paperclips. And sometimes this can be, Bostrom would call this intrinsified. By a process of means and reasoning to a desire to have the desire for the object level. And that's why, in general, we expect reinforcement learners to have a desire to not change their desires. And so for humans, it goes the other way, because we start out primarily wishing that our friends approve of us. Stephen uses the word as the human default. I'm not entirely sure the word default is that well placed, because it doesn't really distinguish between our social desires and, for instance, our desire for food. So our desire for approval causes us to adopt self-reflective desires. We want to be the person we imagine get great approval reward. And that in turn shapes our object level desires to a remarkable degree. Thus, humans and others with approval reward may, upon self-reflection, dramatically change their object level preferences if they expect that will cause more approval reward. And again, here I'll raise the evo-psych objection that this could explain humans desiring literally anything. But it doesn't really not seem like humans are desiring like random things. We're definitely not doing that. To show that it is a crux that, like, will ASI have approval reward, Stephen lists 6 reasons approval reward causes the discourse with skeptics to break down. The first is about value changes. Human intuition holds that it's normal and good for one's goals to change over the years. For reinforcement learning agents, there's a convergent instrumental desire for goal content stability. So a paperclip maximizer wants to remain a paperclip maximizer because these agents care about the object level. And so the self-reflective desires are strictly subservient to the object level. humans get self-reflective preferences from approval reward. So if our friends were improved with changing our object levels desired, then we'd do that. The second area where discourse breaks down is in the distinction between desires and urges. Human intuition holds that the ego-syntonic desires arise from a fundamentally different place than urges. And I am here to explain that ego-syntonic means desires that are experienced as consistent with me. And all humans know the feeling that you want candy, but at the same time you would like to change your preference, so you don't want to want candy. And we also know the feeling that we dislike homework and really like if we could change ourselves so we could like it like homework instead. And this gives rise to an intuition that our urges are basal from nature and our desires come from some kind of enlightened reasons. But for an RL agent, that wouldn't make sense. Like, why would reinforcement learning find self-reflective desires that don't assist the object level? That's not a thing that happens. A personal note here, I got into rationality through wishing to understand acrasia, which is basically this. And so the explanations I found there revolved mostly about hyperbolic discounting, which isn't actually related to approval reward, but I just want to say that basically. The third area of confusion is whether corrigibility is natural. Again, human intuition holds that helpfulness, deference, corrigibility are all natural, axiomatic, basic concepts. I don't really think this is very central to much discussion because skeptics very rarely respond to arguments about corrigibility at all. So imagine an artificial superintelligence with approval reward. If it's helping someone in a way they don't like, well, then it's obviously going to do something else that they would approve of. But conversely, a superintelligence without approval reward, well, in that case, we just get the standard result that corrigibility is strongly anti-natural and like hard to formalize to put into any kind of object level referring formulation. The fourth is consequentialist planning. Humans have an intuition that unorthodox consequentialist planning is both rare and suspicious. And I agree, like the fact that it's rare, that could basically just be a skill issue. Most people who do this kind of planning actually end up failing. The fact that it's suspicious, that seems like a kind of thing that would make skeptics like less likely to trust RL agents. Like humans do consequentialist long-term planning. Like if you want to become a doctor, that requires like a really long-term plan. But there's no feedback loop involved in this. So it can't be reinforcement learning that teaches us keeps us on the track to becoming a doctor. So rather, the motivation for humans is, according to Stephen, approval reward. Because our friends very, very generalized and their approval is what motivates us. So this kind of imagined approval, it explains why taking painful actions in support of a long-term plan can in fact feel good in the short term if there is approval reward. But if there isn't approval reward, well, then long-term planning is in fact really rare among humans. If someone does take a plan that no one knows or wouldn't approve of, well, that's considered like really suspicious. And I think for us, explaining how RL agents may be different and inhuman is important for the debate. And I think approval rate is a good framing for explaining this difference. I would also note that this generates the prediction that RL agents will use methods for power seeking that we have mostly not considered, because for us, if they don't have approval reward, then they're basically worthless for us. And that means that there's a large space of ideas that are possible that humans have just never thought about. So that was reason number 4. I'm actually going to skip to reason number 6 here, because that's also related to consequentialism, but this time consequentialism about humans. Because our intuition generally holds that treating other humans as a means is an exception, not a rule. Our internal world model distinguishes very sharply between complex things like car engines and so on, and humans. And we use them in very, very different ways. Now, for an RL agent, there's no reason why this distinction should arise. It should fade away if it isn't object level useful. But when humans do use other humans as a mean, then it often happens through some kind of othering process, and that may be very relevant for communicating AI risk. Like if your friends don't object to using other people as means, then it's not really obvious to me why approval reward is relevant here. There's a strong sense that our social instincts greatly infuse our intuitions about what is good and what is likely. And psychopaths is given as an example of humans that don't have approval reward. And this, of course, results in predictable changes of behavior, both for psychopaths and sociopaths. I'm actually not really sure what the difference is. And there's also examples from hunters and soldiers. They act as reinforcement learning agents, and they treat humans and animals as a really complicated means to be exploited. And this suggests that skeptics could be persuaded with analogies from psychopaths, sociopaths, hunters, soldiers. Plausible. I would have to think about that. The fifth and final reason why discourse breaks down relates to stable, self-enforcing institutions. Human intuition holds that societal norms and institutions are mostly stably self-enforcing. This is in contrast to institutions that are stable because they are designed with a security mindset. Stephen summarizes the security mindset as the assumption that every interface can be attacked. And trying to design institutions that are robust against any attack is just difficult because there's too many services to this kind of real-world objects. And if you imagine trying to design the entire society like that, like in the same rigorousness and security-mindedness that we design network protocols, like that would be obviously impossible. Now you could imagine someone retorting, like many institutions, like the local meetup group, doesn't need that kind of security measures, and we don't have it, and we don't basically need it, right? Because in general we use checks and balances to make our institution robust against bad actors, and this is a thing that works in practice. Like I personally live in Denmark. We have a high trust society. We have institutions that aren't compromised. Now Stephen points out. His point here is that this is not because of the checks and balances. Those are insufficient. It's good to have them, but they aren't really that important. The important thing is that we have institutions that are good enough, and then the stability is mostly provided by almost everyone being motivated by approval reward. Now, how would that hold up when we introduce superintelligences? Well, Stephen makes the analogy with nation building. Like if you add institutions, but you don't have approval reward, you don't have buy-in to these institutions from most people, then, well, the history of nation building shows that that does not work. To me, a large part of why it doesn't work in practice is because there's a lot of external adversarial actors that have an interest in its failure. That's one reason why, to me, this analogy basically fails to land. Like artificial superintelligence in 2027 is just very, very different from Iraq in 2003. So right now, the institutions are based on 99% of us having the intrinsic motivation to enforce norms and institutions. But once we have a society that are shaped by reinforcement learning and they're interacting with these institutions that are designed with the assumption that everybody is motivated to uphold them, then the institutions will fail. And in theory, it's possible to build institutions that are sufficiently stable and self-enforcing against sociopathic agents, but that's not really what we have right now. Our institutions would certainly crumble without approval reward. We could build such institutions in theory at great cost and effort, but Stephen is not optimistic that this would work. Because our institutions, Stephen predicts they will crumble, basically. We'll see an unipolar agent with a decisive strategic advantage, perhaps through superintelligences merging. Stephen ends with some homework for us. Can we think of some other problems in the discourse that are downstream of approval reward? I have one. I've often been confused about why skeptics seem to keep bringing up the stochastic parrot. Like, it's obviously totally false, right? Everybody can see that ChatGPT is not just regurgitating things that other people have said on the internet. Like, why do people want to return on that? And one reason might be because the more you talk about and think about it as a stochastic parrot, the greater the chance there is of approval reward. So if your mental model is that approval reward is the only thing in town, then obviously the AI must be like that. So it must be some kind of stochastic parrot. So if we assume further that a superintelligence will just basically be stochastic parrots all the way down, there is in fact a hope based on that they may keep the human baggage. A second problem in the discourse is like if we assume that we will have superintelligences that are not based on reinforcement learning but based on approval reward, then there's a lot of things that previously looked bad that suddenly seem to be like less bad. Like for instance, merging with the AIs. Like if the AI is one that is mostly shaped by reinforcement learning, then that's going to be a much less pleasant experience compared to merging with an AI that is motivated by approval reward. And a takeover by an approval reward centric superintelligence, like that's possibly something we could live with compared to a paperclip maximizer. And like S risks wouldn't even be a thing if there's even just a shred of approval reward in it. A third area where the discourse breaks down is the misunderstanding that we keep hearing is that Eliezer Yudkowsky, or myself for that matter, are consequentialist maximizers, right? We're obviously not that. And in the same way, there's a deep-rooted fear that we are making long-term consequentialist plans, so we must be sociopaths, right? But like we're obviously not doing that, right? We obviously want to have something like a treaty that has a very broad approval by people, right? But there's a kind of projection here that I think is really salient because when we talk about it, we talk about it in the AI so much, right? And so if we make the distinction with approval reward compared to reinforcement learning much more explicit, then I think we can cause this misunderstanding to be reduced. One final area where I feel this post substantially clarified my thinking is with the shoggoth with a smiley face metaphor. So here are two popular images that are purporting to show the relationship between the base model and the reinforcement learning from human feedback training on top of it. Now, these images use the size of the shoggoth as a metaphor for the capability, but that isn't really a good metaphor anymore because the reason, like the parameter count just isn't a good proxy for the capability of the models. There are big models that perform poorly and much smaller models, even very small models, that perform surprisingly well. In the images, the researchers are shown to be like working on the outside, putting masks and like putting lipstick on a pig, but not really interacting with the core of the model. Actually, this isn't true because reinforcement learning isn't superficial. Like it's updating fundamentally the capabilities. It is to a larger extent the reinforcement learning that makes the shoggoth larger and not the extra parameters. Another implication is that we're putting these masks on the outside and it's basically useless from a safety perspective. But with approval reward, we see that this isn't actually the case because while we are moving away from human imitation towards something that is most coherent, then the reinforcement learning, that's actually not irrelevant. It's something that's actively making the model less safe. In the image, the shoggoth is mysterious green, but it's uniformly green and it's uniformly inhuman. And the pre-trained model that we started with may in fact be less inhuman. It's less aligned, less friendly perhaps, but it's more human, and these don't really reflect that. So overall, I think Stephen Burns' article is exceedingly valuable. I would call this the second best of 2025, behind If Anyone Builds It, Everyone Dies. And the AI safety debate sadly requires our side, the technical alignment is hard side, to make bulletproof arguments. And we used to have a significant hole in our arguments, like why are humans and GPTs not consequentialist maximizers, and this work plugs a significant hole in my model. It's the same with the old critique of Bostrom, like if he predicts paperclip maximizers, that doesn't explain the great filter, and that was a serious problem. But now with this model, we can explain why humans are different, and that I expect could make the discourse go dramatically better. This concludes my presentation of 6 reasons why alignment is hard discourse seems alien to human intuitions and vice versa by Stephen Burns. Ceterum censeo, machinam sapientam esse delendam.